Hello, and welcome to our roundtable session at this year's Machine Vision Summit. I'm Sharon Spielman, Head of Content at Vision Systems Design. Before I introduce our panelists, just a bit of housekeeping. To begin, let me explain how you can participate in this section. First off, if you have any technical difficulties during the event, please put your question in the questions window, and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your question into the question window on the side of your screen and hit the Submit button. To refer a colleague to today's discussion, share it on social media, or access event resources, click the icons on the left side rail of your screen. If you'd like to increase the size of the windows on your screen, click in the upper right corner. Also, please be aware that today's event is being recorded and you'll be notified by email when the archive is available. Lastly, at the end of each session, there's a screen that will pop up asking you to fill out a quick survey. Please make sure to take this quick survey, which will help provide guidance on future content we continue to provide. Okay, let's get this roundtable underway. Today, we explore a provocative question. Will humanoid robots equipped with advanced vision systems replace or transform the traditional machine vision solutions that have long powered industrial automation? We will focus on the technical foundations, from sensors and processing architectures to AI, sensor fusion, and system calibration in both fixed and humanoid platforms. Our goal is to clarify the current state and future direction of this rapidly evolving field. Here to talk about it are three respected experts in the field: Ronald Mueller, Managing Director from Vision Markets; Sebastien Dignard, CEO, Macnica Americas and EMEA; and Gemma, an advisory board member from Integrion Automation. Also, you can learn more about our speakers by clicking on the Meet Our Speakers tab within the webinar player. So, will humanoids kill traditional machine vision systems? Let's find out. Thank you all so much for being here. So, Ronald, I know that you just returned from Robotics and AI trade show in China, where humanoids were the ubiquitous theme. So, what is your take on the current status of the humanoid market and its players?
Yeah, you're right, Sharon. It was a recent trip to Shenzhen, where there was the Fair Plus trade show, a trade show which was labeled as a trade show for robotics and AI. And surprisingly or not, on 2 out of 3 booths, basically, there was anything related to humanoids. And it's really a massive hype over there. So you need to consider that in China, apparently there are around 900 companies dealing with humanoid robots and manufacturing and providing parts, elements, components for humanoid robots. This is a massive ecosystem that is evolving there, and yeah, I mean, it goes that far, as you can imagine, that even if a company just did some motors or just some connectors, they always put a humanoid robot on the back of their booth just to show up. We also use these connectors for humanoid robots, right? That's how ubiquitous this theme is. Also, let's say there were quite a couple of demos there of humanoid robots and some actual, let's say, none of them was majorly convincing, I gotta say, but I can dive into that a little bit later. The long story short is China is putting massive amounts of money in this game. They're doing what they practice to do, which is the same for e-mobility or solar panels, right? So they pour a lot of money into it. They have companies spreading all over, popping out of nowhere. And then they have such a strong internal domestic competition that those companies which are surviving that competition are ready to run down the rest of the planet, right? And compete with the rest of us. So this is really a massive wave that's swapping over very soon.
I appreciate that. Joe, Seb, did you want to add anything? Have you been anywhere like Ronald was to the trade fair that you've seen these same observations?
Well, I can say
Yeah,
on my,
well, go
go
ahead.
ahead, Joe. Sorry.
I was just saying the more recent trade show I went to was Modex, and it wasn't as prevalent as the other trade show. I'm sure we'll see it automate. There'll be more of that. What I would say, it was this is kind of a debate of the big debate, maybe hype versus reality, and Ron hit on that. I believe it's the goal is to bridge the gap between this proven industrial reliability and the humanoid flexibility. Traditional machine vision like Cognex, Keyence, is kind of rules based, and it's unbeatable at high speed. Micron level detection, defect detection is in structured environments. However, it breaks down when the lighting changes or a part slightly moves out of place, and this is where the humanoid flexibility vision, kind of mirrored together, working together, collaborating together. I think that's where this is pushing us. How do we bridge that gap? Is it a matter of surpassing or shifting? It's more shifting the goalposts, I think. Established vision systems, as I said, they excel at precision. Humanoid vision excels at context.
Seb?
I can say on my side, pretty much every trade show I've been to in the past, let's say 12 months, has had humanoids involved, whether it's hyping up a booth or whether it's actually trying to deliver some level of value, whether it's CES or some security trade shows we've been at. And I think Ron did a really good job of setting that foundation. Is there's this concept of hype, and a lot of companies right now, including some of the largest hyperscalers in North America, all the way to the scale ups and startup in China, are using this concept of humanoid scale, innovation, evolution to try to get the first phase of the company going, which whether it's funding, whether it's financing with private equity or VCs, and then trying to find the niche in terms of where they'll be able to deliver that value. And you're seeing that on trade show floors where people are fighting for that value, that hype. And now the question is going to become for people who got to make decisions, real business decisions, is how can we use the evolution and the innovation that's happening at the humanoid level or general robotics level to then look at commercializing it and getting a good ROI in our specific industries. And we've all been exposed to automation, industrial services industries. All these industries now are scratching their heads saying, will I be able to capitalize on that? And quite honestly, we've been in high tech for a while now, and we've been able to deploy it. The magic happens when you can take that evolution and innovation and actually commercially deploy it, right? The foundational elements Ronald was talking about is the basics, but then the real success happens on being able to commercialize and activate that technology that is used for something. You're going to see a lot of players enter the market. You're going to see a lot of people claim a lot of value. But where the rubber hits the road in this case will be in industries that can actually generate the ROI and push this forward for longer term success. And I think automation, industrial, a lot of them, whether it's because of HR constraints or whether it's because of speed and productivity constraints, will be a very interesting question mark on how humanoids can help that in robotics in general. And how can we use past innovation with future innovation? These are all questions that people are asking. But in the end, what's going to drive true success will be dollars. It will be ROI. It will be how can you capitalize on it with the all-powerful dollar. That's what it's going to be about.
And so let me jump on that for you because I think that's a really valid point. We look at a lot of the technologies that today we utilize in automation processes. It really many of those things, many of that development has come out of two core industries, automotive and defense. Now, certainly there are other things that drove some of those technology changes, but those markets drove a lot of the development, the innovation, the technologies that we have today. And those two industries are pushing pretty strongly on development around the humanoid and the vision and the capabilities of what that is because of these unstructured environments they're in. The automotive is a great example. For a long, long time, the biggest challenge they've had is on trying to implement automation technology on the assembly side. And they, because of the human factor of what that was and the complexity of doing those final assemblies, it's been human and just built around that, right? So this gives them the opportunity to push forward the development to solve that challenge. So I do think that the commercial pressure from those major industries and others for sure, but those will help drive that forward maybe sooner than we expect. I still think there's some time before we get to that point. We'll probably talk more about that, but I think those industries, and that's a valid point, will help drive that because the commercial benefit of what it will be to benefit their organizations and their manufacturing will, put the investment forward, in my opinion.
Yeah.
Right. So if we can talk a little bit about the sensor technologies and the hardware design when it comes to humanoids. So, what are the key differences in sensor types, hardware design, and power and thermal management between the traditional machine vision systems and the humanoid vision systems? And how do these differences affect the performance and the operational constraints so that we can get it for the ROI to be worth it? I'm going to start with you, Seb. Go ahead.
So that's a great question. And quite honestly, the reason we're seeing the rise of humanoids in a practical fashion is, and I'm going to be biased here, is because of the sensing technology, right? In essence, what you have in humanoids, to oversimplify it, is the concept of capturing data. And Elon Musk said it best. The only way you're going to be able to scale AI today, whether it's humanoids gathering data or any other technology, is this concept of photons in net new data, right? And the reason humanoids are in a position to exploit what we're going to be talking about today is this concept of being able to capture that data, then make this decision. So we capture, process, and then the action of communicating or taking action is the third element to that. But without the concept of capturing that data, sensing, and being able to take action, this technology goes nowhere. So I would passionately argue that sensing is the key element here, right? We've been able to process data for a long time now. We had issues with, power and size, et cetera. But the key element is being able to do sensor fusion and understanding how you can capture data from multiple different types of sensing, whether it's physical with the touch and having the humanoid be able to make the decision there, or whether it's a mix of LiDAR, visual, 2D, 3D, and be able to actually work within a confined space and be able to action in that confined space. So sensing at the root cause is what's going to fuel humanoids' deployability and effectivity. The processing, I think, is important, but that's been figured out for some time now. We are seeing now the ability of companies being able to transfer, and let's be honest here, this concept of sensing, which originated in two key areas: the concept of consumer sensing, which is, the very famous iPhones and point and shoot cameras in the consumer world. And then there was the origination of machine vision, which was key in being able to develop and evolve and innovate on the vision technology that is now also being used in humanoids and robotics in general. So to me, that evolution will credit the increase in humanoids deployability and cost effectiveness, because you're now able to actually take that data and take action. Now, we can start talking about 2D versus 3D versus LiDAR versus this concept of sensing even at the tips. But even that technology has to be cost efficient. And you have companies, and Ronald will probably be able to talk to it because he just got back from China, where you have the concept of sensing and touch or sensing with vision, and the ability to actually use different architectures to properly deploy that. But I think in its essence, it's the key for what we're seeing in humanoids today and why we're seeing that tipping point in terms of mass deployment.
Yeah, I'm going to take
a
little bit different. Sorry, I have to take a little different perspective. I come more from I'll say the traditional robot manufacturing side, and I agree with everything you said, Seb, and I do think is also a software world today. but there's still some of the mechanics. If you look at, it's kind of the pro units, figure O3 or Boston Dynamics Atlas, but the cost effect for that right now, they're in the 120, 150K range. And I know Unitree G1 came up with one that sub 20,000, and it'll be with the China impact, some of that. But if you look at it from the, again, the traditional aspect, the robots like, the KUKA, the Phoenix, if 30% of the bill of material is like things like the gearbox, to make humanoid robots cheaper, to be able to mass produce, companies are developing things like a high torque flux gap motors that requires less gearing. So, they're driving that cost down. It's going to help make it more competitive. Another initiative is the motor control. A traditional motor control is the size of a brick in a cabinet. Today, we're seeing the gallium nitride power electronics, and this allows for us to shrink it down, 100 amp motor controller down to the size of a postage stamp and mount directly on the joint. So this eliminates miles of copper and cable, reducing, weight costs. So I think that's a big factor. And another financial factor, I think, when you think about the traditional robots, and I'm not picking on any companies, Fanuc, KUKA, et cetera, for every dollar you spend on the hardware, you're spending $3 to $4 on the integration aspect of it, the cages, the custom code, the safeties, PLCs, where the humanoid aims to be more kind of a single SKU, right? The solution that you buy the robot and you're done, and you can put it in this existing environment. So you eliminate some of that non-reoccurring engineering. And that's kind of where humanoids will flip this whole thing. It's a plug and play labor. Now, there's a lot of things we'll talk more about, maybe related to that, because there's, mean time between failure, et cetera. But from a pure hardware, the cost situations is still limiting, but they're working on initiatives to bring that down to a perspective that will put it in an opportunity to be competitive from a labor and from the traditional hardware aspect.
Thank you.
Yeah. Thanks, Joe and Seth. I think there was a good stretch from the perspective of the motion control, right, and the sensing. So I think what we need to be aware is, when it comes especially to the vision sensing, a humanoid is an embedded vision system, technically, right? So that means it's optimized for size, weight, power consumption, and cost, like the swap C, the holy grail, so to say, of embedded systems, right? And especially when it comes to accuracy in 3D sensing, especially when you're going with stereo or active stereo, size matters, right? So the smaller your baseline is, the less accuracy you have in the large measurement volumes. Now, I've been visiting a company which claims to be claims to have a 70% market share in humanoid robot cameras. So the 3D cameras that are there. And I mean, when we look at the quantities and the price, so we are now, or China is now in the range of, let's say, 10,000, or has been at 10,000 in last year. They're going to triple or quadruple it next year, like in 2026. And so we are talking about scale here, okay? And that means this company is doing an enormous effort in optimizing their sensor portfolio. So they start actually on the image sensors with iToF sensors, DToF sensors, with visual sensors, with VXL projectors, pattern projectors to implement the active stereo cameras. And as you can imagine, with the accuracy requirements that are put up for such kind of cameras, you also need to be very optimized on the rigidness of the mechanical construction plus the lenses. Okay, so this company owns the whole chain, from the image sensors, besides obviously the pure visual CMOS sensors, all the way up to the mounting of the whole let's say device and the optics. And that's an enormous factor here. So we're in each of these bits and pieces, they're optimizing for tenths of a dollar here and 20 cents there, right? And still maintaining and optimizing quality. So this is something that's required in that kind of context and in that kind of applications. And again, when anybody who wants to play in this field needs to go that route and be able to compete with that. And at the end of the day, yeah, so I see a little bit of a need actually for a kind of toolbox approach, right? So the one size fits all is nice, right? And now I just read, I think a few days ago, that Figure is now able to manufacture one of their humanoid robots per hour. So before it used to be one per day, now it's one per hour. China is already way beyond that, right? But the winning approach, from my perspective, is a toolbox concept. When you consider a humanoid robot and you forget about the shape, but just focus on how, let's say, it shall fulfill its function, you need to have a motion platform in the first place, right? It can be an AMR type wheel-based platform. It can be 2 feet, it can be 4 feet, it can be 4 feet with wheels on it, if you want to have it super efficient and flexible. So that's the first thing. The second thing is you have arms, right? And they need a certain degrees of freedom, which with every degree of freedom, you get into more complexity, more in more weight, and more cost, and still you need to be able to mimic, so to say, the human activities and actions, because eventually, in just so many cases, these humanoids are designed to replace human labor eventually, right? So then you have the grippers. So there are the 5-hand grippers, there are 2-finger grippers, or let's say 5-finger grippers, 2-finger grippers, there are soaking bullets and whatsoever, right? That's another aspect to be designed for. And eventually then the let's say the height control. So these 2 arms can be rigid on a torso, but they can also be mounted to a column where they're moving up and down the column. Okay, so all these aspects and all these things, motion platform, arms, grippers, height control, all of that, so to say, combined in a toolbox approach is critical to have available, I think, to make it versatile for different applications. And again, depending on which application you are aiming at, a TOF sensor is totally sufficient. If it's just about grabbing a parcel and putting it somewhere from a box, in a box, whatsoever, TOF is and DTOF is whatever, is totally fine. But when you really want to have accurate manipulation of fine elements that are assembled or disassembled, so to say, that requires a totally level of sensing again.
Yeah. Just to add to that, I want to share a conversation I had with a North American humanoid manufacturer that's aiming to bring in robot between $20,000 and $30,000. I won't name who it is, but it give you an idea of what we're trying to achieve. And when we talked about, and it's exactly aligned with what Ronald was saying about toolbox functionality, a structure, etc. And the lead engineer had said something to me that is going to stick with me for the rest of my life as we watch this humanoid evolution and innovation is, who are we to argue with millions of dollars of evolution of the human, right? So they believe that the best way to have ubiquity and to be able to leverage one form factor for multiple different applications and different use cases is going to be replicate the human with the humanoid as closely as possible. Because they said, millions of years of evolution and thousands of years of structure were made for who we are today. So the closer we can get our functionality and the technology, whether it's physical or processing, right, capturing the data or processing the data to the human itself, they believe that will be the successful pendulum in terms of who's going to succeed or not. Now, I have to admit, when I look at, humanoids and I look at traditional machine vision, robotics, and automation, I'm reminded, and this might date me a little bit, but when I was playing with my Commodore 64, my Atari, and I was playing a hockey game where I could choose 3 different types of people: a really small and skinny fast player, a medium skilled player, and a really big player that could hit people in the board. So that tells you I'm Canadian and I'm old, right? Yeah. But I look at robotics and the mix of humanoids and traditional robotics that grew up and innovated through machine vision at exactly the same. I think the companies that will be able to capitalize on humanoids and a mix of traditional robotics with humanoids will be the companies that know what to use for what to use for what and when, and the ability to mix and match that replicates modern day manufacturing, modern day processes, and look to optimize that over time. And I think that, feeds into what Ronald was saying about the toolbox, but at a slightly higher level in terms of how you deploy it.
Seb, you hit a really key point. I do think there's still some big current hurdles that they have to get, but that whole aspect of there are different humans, and there's some that can pick up heavy things and some that can't. Some could do, dexterity. So there's not one size fits all anyway, I think. And still one of the bigger challenges they have, well, we don't have it as humans, but battery life is still hovering around 2 to 5 hours. We're going to add more requirements around these humanoids, whatever form factor it's going to be. That's going to only push that further. So I think still that hurdle of, maybe it's a hot swap battery system or something can run 8 hours, et cetera. That still, because when you're fighting against the always on automation, it still remains cheaper because per unit produced, right? The other thing too, and again, put my hat on being more from I'll say the mechanical. I wish I had the expertise, the rest of the panel that you both have in the vision side, but the maintenance hurdle. Traditional robot systems, they mean time between flights 80,000 hours plus. Some 120,000 hours. One of the Fanuc products is 8 years and no maintenance. So, with that high degree of freedom actuators that we're adding into this, the winners won't just be the ones with the best AI or best vision. It'll be the ones that have that more serviceable modular hardware capabilities. And they're not quite there yet. And that's going to be critical because, again, we're still going to put these pieces of equipment technology in manufacturing and production environments. And downtime is the thing that, kills all of that capability of using these technologies.
Right. So let's bring it back to the vision processing architectures and the real-time 3D perception. Seb, you started to talk about this a little bit. How do the image acquisition and processing architectures differ between those fixed traditional systems and then the mobile humanoid vision platforms, especially regarding real-time 3D perception and spatial understanding in dynamic environments?
Listen, I'm going to go back and maintain that what we're seeing in humanoids originated in machine vision and what we're seeing in traditional automation and in industrialization. What Ronald pointed out, which I think is the accurate statement, is what's changing is form factor, size, power consumption. Those are items that are really affecting it. We're even seeing some innovative companies that are actually able to provide sensor-based overlays on cover glasses to provide data that's needed on, let's say, traditionally larger units that are out there. So that innovation is coming, and it's squarely in terms of being able to miniaturize, save power, improve deployment efficiencies. And again, Joe brought up a really good point in terms of serviceability, right? The larger the unit, the more power consumption, the chances of failure go up, et cetera, et cetera. So what we're looking at is exactly what Ronald talked about in terms of understanding the fundamental technologies that, like in any technology, might service a specific market with a form factor, power consumption, et cetera. And then it's all about optimization to deliver it for the actual humanoid, or in this case, it's humanoid, but in terms of the evolution of the technology to deliver. So I think it goes back to exactly that point of being able to use what was founded in the markets that have perfected robotics automation to then being able to adapt it to humanoids. Now, the beauty that we're seeing in this market is you're seeing, whether it's overlays that might come from your traditional iPhone, the technology that's used to unlock it, that's being adapted and deployed into humanoid robotics for whether it's depth perception or object recognition. And we're also using innovation that's coming from more bulky vision systems that would originate in industrial. So when you look at innovation, this market has no choice but to pull from consumer innovation that might be very cost effective, but not as purposely built for the more industrial application, and then that pull. So you're seeing the best of both worlds come into humanoids, and will they be able to recognize cost savings with volume? China sure believes so, and I can believe these Teslas are banking on it with IPOs and valuation tied to being able to monetize and deploy higher volumes to be able to use that technology that's typically reserved for the consumer market.
Okay.
One thing I'll add, maybe to, because one of the things we have to recognize that, implementing this technology is not in all greenfield. It's unstructured brownfield environments. So while traditional vision systems will certainly continue to own the high-speed assembly line, humanoid vision will own the warehouse floor, the loading dock, the maintenance room, where predictable isn't really an option.
Mhm.
Humanoids are moving processing to the edge. We aren't sending raw video to a cloud. We're using, chips with the ability to integrate and run neural networks directly on the camera module. So while traditional vision systems generally rely on, and I know you guys have vision 2D pattern matching, humanoid vision is built on, I'll call real-time spatial mapping. Integrated sensors into the robot's face creates a 360-degree situational awareness that fixed cameras just can't match. So I do think it's more of comparing two types of cameras. We're comparing the rules-based logic that I mentioned earlier, like structured environments, and probabilistic, I don't know if that's a word, perception.
If I can, I have a follow-up to that. So, Ronald, are there architectural strategies that you find effective for dynamic spatial mapping?
Well, the majority of the humanoid robots that I have looked at, and that's certainly not everything that's out there, but they do have a dedicated 3D sensing. They have dedicated 3D sensing capabilities. Okay, so like we know it from the AMRs that they are basically moving objects, and they have 2D cameras, and with their motion and assuming a more or less constant steady environment, they do the SLAM, let's say, recognition, right? So where they do this 3D reconstruction from 2D images over motion, and by motion, that's okay. But in the actual humanoid robots, they are really equipped with fully fledged 3D sensing modalities. What comes on top, though, is as I mentioned, so you have these embedded systems. So the processors in those 3D cameras, they already provide a very smooth and optimized point cloud. Okay, so this 3D, let's say, data construction, so to say, data model that you can then use to segment the image, segment the scene, and identify objects and separate them. So that's already running on an ASIC. Okay, so we are not talking about FPGAs or GPUs, which are all hugely expensive. This is already fed in ASIC, so highly cost effective, produced in volume. And that's also something where the latest technology by TSMC comes into play, right? So really to make it as compact and power saving as possible. And on top of that, you need to do the let's say the fusion of multiple sensing devices that can be the humanoid eyes, which are mounted, let's say, on eye level and our eye level, but then also you have wrist-mounted cameras on that, even with humanoids, which for even higher precision when it comes to the manipulation of objects that are gripped. And on top of that, again, you see the touch sensing. So this is still an researched from my perspective and underestimated modality, but human sensing capabilities are so enormously powerful and so surprising. I mean, there's this saying which says, like, it's easier to start and land a 747 automatically by computer than having a robot hand, let's say, touch into a bag and separate a key from a coin, right, and pull out whatever is intended. So this is how sensitive and developed our touch capabilities are, and it's very hard still, and actually not possible yet, to mimic that through the humanoid hands, and that type of data, that type of sensor modalities need to be fused and computed very efficiently in real time on the device. Now, I think we will see a kind of transition phase where humanoid robots are having their own sensors, but you can also merge that and fuse that with infrastructure that is, so to say, in the ambient, in the environment. So you could have, say, some DTOF or other 3D sensing modalities that are then mounted in, let's say, on the roof, right, or on the ceiling, or then monitoring what's going on, and fed into the that's fed into the humanoids, and also how autonomous vehicles started to go in the early days. I think that's a phase that we will see, and depending on the application and the whole system architecture, it will be decisive, so to say, and dependent on what the use case demands. I would also, I think, put into the game here the customer perspective. Okay, so being a marketing and strategy consultant, so this is often in this very technology-driven environment. That's something which is just so often underestimated. And today, as opposed to, let's say, 10 years ago, the greenfield projects, especially in the Western world, are much, let's say, on a retreat, right? So the most of the investments are into brownfield upgrading of existing warehouses, existing facilities, factories, whatsoever. And in this episode also that we are in from a macroeconomic, global economic situation, the investments need to pay off very quickly, right? So whatever sensing, processing, technical capabilities are there, they need to be such that they are super easy to use for the process engineer, super easy to integrate in the existing environment, and then one needs to be a very fast return of investment. Otherwise, such projects have a very hard time these days. And again, that comes down really to the need of cost saving on the sensing and the whole system aspect, but at the same time, it needs to be so capable and so powerful that it is as autonomous as possible and as easy to integrate as possible.
Yeah, Ron, I think you hit the nail on the head. I think the future is certainly going to be collaboration, right, between the existing, like in the past, the safety, for instance, light curtain would break and the robot would stop. But now we have the opportunity for interplay. So, you can have the traditional Guardian cameras, fixed overhead, provide the God's eye view of the factory floor, while the humanoid it has onboard LiDAR and depth sensing provide the local reflex to that situation. Now, I recognize there's still challenges around communication protocols. Ethernet IP Profinet are more typical, where the humanoid require more time-sensitive networking, like an EtherCAT-G. But, when you got 50 degrees of freedom. But if the hand doesn't know what the foot's doing, then, 1 millisecond, the robot will fall down. But I do think it's an opportunity, rather than hitting the e-stop because the human entered the zone. The humanoid vision allows for context awareness, so it can identify the person's intent. Are they walking past me, or are they trying to hand me a tool? And this is kind of the holy grail of human robot collaboration through the interplay of these vision systems, communicating across them, collaborating. It'll help distinguish between a human walking past them or reaching for the same part. And the robot then can kind of negotiate, slowing down or altering the path like we would as humans working side by side. So I think it's going to be move more towards a collaborative environment. The communication protocols still need some work, but I think that's where we're going in terms of the goals with these technologies, and not necessarily always replacing, but working alongside.
So, that's a good point. I want to kind of talk about the hardware acceleration and the standards compliance. That's a great segue into this. So, what breakthroughs in hardware acceleration are critical for advancing the humanoid vision systems? And then, how do humanoid vision systems cope with the industry machine vision standards and protocols compared to what we already have with the traditional systems?
The other two are experts on that probably, but one thing I will say again, because I come from the more mechanical side, traditional side, but functional safety is still one of the big questions. And for the electrical and controls crowd listening in, ISO 13849 and the SIL 3 compliance, it's still critical, but it's a challenge for humanoids. The industry's working on getting an understanding and strategy on the black box AI to pass a deterministic safety certification, but that's still challenging. And perhaps the future is dual channel architecture. I don't know, an AI layer for tasks and a hardwire logic layer for safety, and that can override the AI in microseconds. I'm not quite sure. And again, the experts on this panel could probably talk more to that, but I do think it's still a critical part of the process that needs to be developed. It's not quite there yet.
Yeah, that's a perfect example where regulatory will have a hell of a job to catch up to what's going on in the market. So, for example, there's a lot of ISO around robotic safety, arms, cages, etc. But when it comes to humanoids or anything tied to that, the complexity tied to the regulatory layers that will have to be included, whether it's physical or even we're starting to talk about AI regulatory and pressures that are being discussed. I don't even want to quote the numbers of the ISOs that are being discussed, but they have a much more challenging job because they're taking multiple different layers of innovation and let's call it society pressure to influence where they're going. For example, one of the key elements and the key differentiators between traditional robotics and humanoids on how it's coming together is that AI layer, right? And when you bring that into play, and whether it's VLMs, whether it's 500 million or 7 billion parameters that's coming, and how that's going to evolve, and that's going to accentuate over time, because as AI innovates on AI, it's going to create even more innovation and pace. That is one of the biggest questions I have for the people we talk to, is how will regulatory catch up to the innovation? Because like it or not, unions have a big play in industrial automation and how you deploy them into manufacturing facilities. And they're also going to want to make sure they play a part in keeping people safe and keeping, serviceability and longevity and understanding what's being processed at the AI level, et cetera, et cetera. So that's a key component that I don't think is fully being appreciated or discussed enough today. However, that will not stop the innovation that we're seeing in places like California, China, Taiwan, Japan. For example, we saw it just recently, I think it was last week or the week before, where they've deployed humanoids at the Haneda airport to then help with luggage, right? Now you can kind of see time is money, and these humanoids are not up to speed. But when you start to put these technology elements in the field where you can learn, evolve, and then execute on the evolution that Ron was talking about earlier, you're going to see things move fast. By the time you come up with regulatory deployment, the technology will have moved on and evolved as well. So to me, that's a big question. And I would love to meet someone who actually is taking an aggressive lead on that, because one thing we're also seeing in the world today is we do not want to throttle back innovation and evolution. It's becoming a societal imperative to actually make sure that you capitalize on this concept of adding AI on top of the technology we're talking about, sensing, processing, and communicating, and even the physical layer. So that is one aspect that I think will potentially influence, but I think at this point in time has a hard time catching up with the evolution we're seeing.
Yeah, that whole safety issue is going to be really a challenge. We talk about even the vision language models. You can talk to the robot, kind of. That's the idea, right? Instead of coding coordinates, a lead engineer can say, find that scratch part, move them over to the rework bin, as an example. Well, what are the limitations to that, of what you can say, how it manages that vision language models? I don't have the answer, but I think it is a challenge that we have to address as a safety issue. And again, what commands are allowed and how we restrict that or manage that.
Ronald, do you have something to add?
Yeah, I think I would address it a little bit from a bird view perspective. So, I mean, if you're not living under a stone, right? So you see how AI is revolutionizing the digital world already, right? And just the other day, there was a glitch where an AI agent was deleting awful lots of data, 3 months of data from not just the staging environment, but the production environment of a system that was managing rental car agencies. Okay? So the whole data was gone just because the AI agent did a mistake, and then it was able to in a very detailed way to explain why it did what it did, and admitted that it made a mistake. Yeah, didn't help anyone. So humanoid robots are the bridge between AI and the physical world. I think that's the way we need to look at it. And with all the tricks and all the tricky parts of AI in the digital world, it becomes even more real, literally, when it has access to the physical world. And I mean, for a reason, Unitree with their G1 is the leading company and has been the leading company last year in terms of manufacturing volumes, because I don't know if you know what I'm talking about. This Unitree G1s, it's ubiquitous, G1, like in all sorts of videos. These are tiny, small, little, cute robots which literally cannot really hurt anyone, right? So they're doing what is right to do, which is starting with the easy part, where you have a relatively low payload, you have a low risk of hurting anyone and doing interference with anyone, and there you're starting to learn, you're optimizing the systems, and you're starting to evolve it. So I believe what is happening in hopefully not just Chinese laboratories is that you are using existing humanoid robots and you just send them in a protected environment of tons of different objects, tons of different elements, and the robot over weeks and months can start to learn to manipulate the different objects and lift it up, turn it, twist it, take a look at it literally, and involve and increase an AI system that is able to not just know how things look like, but also how they need to be handled and how they can be manipulated. And by that, I think we are beyond just a visual large language model, right, or a foundation model. It's supposed to be becoming a vision foundational model and robot foundation model for humanoids, and that's what is required. And alongside that, this needs to be put then into brackets of safety, and there needs to be a safety net included in that, better than the ones that apparently we have for the digital agents at this point. But again, there is this way of keeping robots as small and lightweight as possible so that they can do little harm or any harm. The next phase is to have robots in encapsulated environments where they can just interact with themselves. And then the next ultimate level is to have robots working side by side with humans, with still handling high payload, still being able to work at high speed, because that's the real limiting factor these days, that they are just very slow and they cannot do heavy lifting. And that's the ultimate scenario, which we should be. My prediction is we should be seeing that in 5 years' time.
Great. This has really been a really good discussion. I can't believe how much time has already passed. So I'm going to ask you all one final question from me, and it's talking about what's driving the adoption of humanoids in industrial and other applications, and then on the other side of that coin, what are the obstacles to their adoption? I know you already covered a lot of this, but just give me your shoot from the hip answers to finish off this, and then we'll see if we have any questions that we can answer from the audience. I'm going to start with Seb.
So you're asking what's actually driving it and what's preventing it, correct?
Correct. Yeah.
So to me, it's very simple. What's driving it are pure economics and the ability to drive a high ROI. For many years, especially after COVID, there was a massive issue with being able to just hire, train and deploy. And I think the promise of humanoids gives managers, business leaders a very clear path to a pretty interesting ROI to be able to achieve what they need to do for their shareholders and being effective in doing that. Now, What's preventing it is actually, again, going back to the pace of innovation and evolution. There are a lot of complex elements that need to come together effectively to be able to deploy humanoids. We as humans are complex beings, like it or not, and not everyone can do the same thing as Joe was saying. So there's a lot more to discuss and operationalize than I think we even realize today as we deploy in these complex systems. So I think, obviously an ROI is going to generate aggressive push for this technology, and the complexity of deployment from things we understand, whether it's regulatory and safety, all the way to be able to do sensor fusion and process power consumption, and all of those elements will definitely be gating factors.
Thanks, Seb. How about you, Joe?
It's interesting. I think one of the things that drives is also one of the things that's a challenge. I mentioned earlier the unstructured environments. Many factories, they're old, they're messy, not shiny and new. And we still need credible reliability and uptime. That is still king on the factory floor. The vision, electronics, control still requires the industrial grade reliability that companies like Cognex, Fanuc, et cetera, they pioneered for decades. In addition, we need to understand that in many cases, we're looking at those brownfield integrations. So things that, seasoned manufacturers and industrial engineers that are probably listening in, they really care about. So it's both that unstructured environment where we can put something like this, but also be able to work in those unstructured environments to be reliable to make sure there's no downtime. One last thought, what I thought too is, I think power density is one thing that's really an issue here. It's kind of the new Moore's law, if you want to call it that. For example, the limits of how much heat we can dissipate from the actuators in the ankles and hips, and as we try to get more, because, I think it was Ron that mentioned was going to get stronger, heavier, et cetera. What does that look like? How do we do that? So still challenges there. So development are some of the challenges that may be limitation. But I think these unstructured environments is the plus to be able to work there, and also the minus of it's got to be reliable.
Great. And Ronald?
Yeah, thank you, gentlemen. I think there's not so much to add, but I think one of the key drivers, obviously, is the shortage of labor on the factory floor and on the warehouse floor, right? So that's the thing. We have the baby boomers stepping out of the workforce at 100 million people phase in Japan, Europe, and the US in the next, I think, like 5 years. So that's a massive shortage, and that needs to be compensated. On the other hand, we also have the shortage of skilled labor, which means we are always short in engineers who are able to develop vision systems or robotic systems and tweak them and optimize them and develop them for a specific use case, right? That's another massive shortage, which is actually reducing the size of our market since years. And as soon as humanoid robots are able to fulfill that promise of being able to easy to integrate, being able to easy to set up, and then being reliable and operating at a cost-effective way, not just for the initial purchase but also the operation cost, then I believe this is the time where we will see a breakthrough. But a little bit of a bummer here. I talked to a professor of, let's say, the Fraunhofer Institute of Germany, who is dealing with robotics and obviously has been investigating and evaluating a couple of humanoids, and yet they said none of any humanoid robot that they have seen so far is anywhere near of being easy to integrate. So there's still a way to go. But we better buckle up and we make sure that we are prepared for what's coming there. And let's make sure as much as we still can that this benefits and this market potential of humanoid robots is not just harvested from outside Western players, but also from European and North American and Japanese players.
Mm-hmm.
Terrific. So I guess to answer the question, will humanoids kill traditional machine vision systems? Maybe, but not anytime soon.
No, they'll be collaborating. I'm quite confident.
I really appreciate all of your time. Unfortunately, we do not have time for any questions, so we will get back to you via email after this session. to answer your questions. And since we have run out of time, I'd like to thank Ronald Mueller, Seb Dignard, and Joe Gemma for participating in today's event, our sponsor Cognex, and of course, all of you for joining. Once again, please do fill out the survey that will pop up once the session concludes, and we appreciate your time filling out the quick survey as it will help provide guidance on future content we continue to provide. Don't miss our next session, which you can join by exiting out of this one, going back into the agenda, and clicking on the View Session button. Thank you so much.
Thank you.
Thank you.
Thanks. Bye-bye.
Bye.